What if everything you learned about science in school was a lie? Not a small mistake, a complete misdirection. You memorized the steps: observation, hypothesis, experiment, conclusion. Teachers repeated it, textbooks printed it. You believed it without ever asking one simple question. Does science actually work this way? It does not. Richard Feynman, one of the greatest physicists who ever lived, explained how science really works, and his answer shocked everyone. He said the first step is to guess. Just guess. That sounds crazy, right? But wait, what comes next is even stranger. Feynman revealed why science can never prove anything true. Ever. It can only prove things wrong. This single idea changes everything you thought you knew. In the next few minutes, your understanding of science will collapse, and something better will replace it. Stay with me until the end. This will change how you see every scientific claim you ever hear again. If you find this valuable, please like this video. Subscribe to the channel. Your support helps us create more content like this. Now let us begin. What you think science proves. You believe science proves things true. You think scientists observe, test, and then confirm facts forever. This is what school taught you. The words sound right. Hypothesis, experiment, proof. These words make you feel that science delivers final answers. But here is the problem. No experiment can prove a theory correct. It can only fail to prove it wrong. Think about it simply. You test a guess 100 times. It works every time. Does that mean it will work the 101st time? No, it only means it has not failed yet. We use words like proven and confirmed loosely. They make us feel safe, but they hide the truth. Science does not collect permanent facts. It collects ideas that have survived testing so far. Tomorrow, any idea might break. Your confidence in science's proof came before you examined how proof actually works. That confidence must go, not because science is weak, because your picture of science is wrong. The real method is stranger and more honest than the textbook version. How certainty feels versus works. When you hear something is scientifically proven, your brain relaxes. You stop questioning. This is a mental shortcut. It saves energy, but it creates a false picture. Your brain treats agreement as truth. If many scientists believe something, it feels permanently correct. But agreement is not the same as certainty. History shows us this. Scientists once agreed on ideas that later broke completely. We evolved to make quick decisions. Fast judgment helped survival, but fast judgment is not accurate judgment. When examining how science works, speed becomes a problem. Nature does not care how confident we feel. A theory can feel absolutely true to every scientist alive. Nature will still break it if it is wrong. Your internal sense of certainty measures nothing about reality. It only measures how comfortable your brain has become with an idea. Feynman's actual method revealed. Feynman described science simply. First, you guess. Then you calculate what your guess predicts. Then you compare those predictions to experiments. If they disagree, your guess is wrong. That is everything. Notice what is missing. No final proof, no permanent confirmation, just guesses that survive testing. Guessing is not a weakness. It is essential. Without guessing, there is nothing to test. The guess comes first. It can come from anywhere. Intuition, accident, dreams. The source does not matter. Only the comparison to experiment matters. This feels unsatisfying. We want science to deliver truth, but Feynman offers something different. He offers a method for eliminating wrong ideas. What remains is not proven correct. It has simply not been proven wrong yet. The textbook method promised certainty. Feynman's method promises only honesty. Wrong ideas get removed. Surviving ideas continue until they fail. The safe cracking problem. Feynman compared scientific guessing to cracking a safe. Imagine you are working on a locked safe for months. Someone walks by and says, try 10, 20, 30. This is useless. You may have tried it already. You may know the middle number is different. You may know it needs 5 digits, not 3. Random guessing is worthless. Good guessing requires knowing what has already failed. It requires understanding the structure of the problem. This is why science is hard. You cannot guess freely. Your guess must fit everything already known while changing something specific. People imagine scientists trying random ideas until one works. This misses the point entirely. Each guess must be precise. It must connect to existing knowledge. It must predict something testable. Most possible guesses are immediately wrong because they conflict with what we already know. When long-held theories break Newton's laws worked perfectly for 200 years. Scientists tested them constantly. They never failed. Then astronomers measured Mercury's orbit more precisely. Tiny errors appeared. Newton's laws were wrong. Does this mean scientists were foolish to trust Newton? No, the laws worked within the range tested. They only broke when pushed into new territory. This is how science actually moves. Theories survive until they meet conditions that expose their limits. No theory survives forever. Every successful idea is waiting for the experiment that breaks it. Scientists cannot predict when this will happen. A theory might last decades or centuries before failing. This uncertainty is not a flaw. It is the nature of knowledge. We trust what has survived testing while accepting it may break tomorrow. Proving wrong versus proving right. Here is a strange fact. You can prove a theory wrong with one experiment, but you cannot prove it right with 1,000 experiments. Think about why. A theory predicts something specific. If the prediction fails once, the theory is wrong. But if it succeeds, you only know it works in that situation. Future experiments might still break it. This creates an asymmetry. Wrongness is certain. Rightness is always temporary. Science moves forward by removing wrong ideas, not by confirming right ones. This feels backwards. We experience science as collecting truths, but actually, science is eliminating errors. What remains is not proven. It is simply not yet disproven. A theory being temporarily right is the best outcome possible. Permanent rightness does not exist in science. Why vague theories survive everything? A vague theory cannot be proven wrong. This sounds like strength. It is actually fatal. Feynman gave an example. Someone claims a man hates his mother because she did not love him enough. You investigate. Actually, she loved him very much. The response comes quickly. Then he hates her because she loved him too much. Either outcome fits. The theory survives everything. This is the problem. If a prediction is not specific, any result can match it. You simply adjust the explanation afterward. Nothing can ever prove it wrong. Real science requires precise predictions made before the experiment. If you cannot state exactly what would disprove your idea, you have no scientific idea at all. Vagueness feels flexible, but flexibility that explains everything actually explains nothing. Why not knowing is the point. Your intuitions have collapsed. Science does not prove things true. Certainty is never permanent. Vague ideas are worthless. Every successful theory is waiting to fail. What replaces certainty? A better understanding. Science removes wrong ideas and keeps what survives. That is all it can do. That is all it needs to do. This feels uncomfortable. We want solid ground beneath our knowledge, but there is no final floor. Each layer of understanding rests on something that might break. Certainty is dangerous. When scientists feel certain, they stop questioning. They stop testing. They stop doing science. Confusion means you are finally seeing clearly. You now understand what Feynman understood. Not knowing is not failure. It is the permanent condition of honest thinking.